Hi everybody, the purpose of this video is to go over section 1.5, and here we are going to talk about applications and modeling with quadratic equations. Yes, we are going to deal with word problems that require us to solve a quadratic equation. So let's go ahead and get started, and here's our first example. Here we have a we have a machine that produces rectangular sheets of metal such that the length is 3 times the width. And it turns out that equal size squares of 5 inches on each side can be cut from the corners so that this thing can be shaped into an open box by folding up the flaps. And if the volume of this box is 1,435 cubic inches, what is the dimension of the original piece of metal? So what are we looking for? We're looking for the dimensions of the box, or dimensions of the metal. What variables should we use? Well, notice that we have the length and the width, those are the dimensions, and the length is 3 times the width. So let's let x be equal to the width, and then 3x will be equal to the length. And now we can figure out our equation. Now notice that we have the volume, which by the way is equal to 1435 cubic inches, and that is going to be equal to the length times the width times the height. Well, once we fold this box together, the length is going to be 3x minus 10. It's going to be 3x minus 5 plus 5, or 3x minus 10. So this means we are going to have 1435 that is going to be equal to 3x minus 10. Now the width is going to be x minus, once again, 5 inches here and 5 inches there for the squares that are cut out once this thing is folded together. So that is going to be times the width is going to be x minus 10, and of course then the height, once we fold this together, will be 5 inches. So there we go. So this is our equation. Once we have this equation, we can go ahead and solve. Perhaps the first thing we can do is divide everything by 5. You can divide this by 5, this by 5, and these of course will cancel. 430 divided by 5 is 287, and then we can multiply this out, and if we do, we are going to get 3x squared minus 40x plus 100 is equal to 287. Now we probably want to get this in standard form, and we can do that by subtracting 287 from both sides, and if we do, we are going to have that 3x squared minus 40x minus 187 is equal to 0. Okay, now this is the equation that we need to solve. Now chances are we can't solve this by factoring. I can't think of any factors of 3 times 187 that might sum to 40. You can try to see if you can figure that out if you want. That's more power to you. We could complete the square. What I'm going to use is the quadratic formula. Okay, and what is the quadratic formula? Well, that is just basically x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where a is equal to 3. B is equal to minus 40, and C is equal to negative 187. So making the substitutions, I will have that x is equal to negative b, which would be 40, plus or minus the square root of 1600, 40 squared, minus 4 times 3 times negative 187, all divided by 2 times a, or 6. Okay, that will reduce to 40 plus or minus the square root of 3844 divided by 6, and it turns out that 3844 actually happens to be a perfect square. Okay, this will become x is equal to 40 plus or minus 62 divided by 6. And so we will have two solutions. The first one will be 40 plus 62 divided by 6, which is equal to 17. And the second one is going to be 40 minus 62 divided by 6, which is going to be equal to negative 11 over 3. Now notice here that our length has to be a positive value. As a consequence, there is no way that this can be a solution. This is actually an extraneous solution. This is the only solution that's relative to the context of the problem. So what we want to do is our solution will therefore be x is equal to 17 inches. Does it make sense? Well, if x is 17 inches, then 3x, the length, is equal to 51 inches. Therefore, this length right here is going to be equal to 17 minus 10, which is 7, plus 51 minus 10, or times 51 minus 10, which is 41, times 5. And it turns out that 7 times 41 times 5 is indeed 1435. 1435. So this does indeed work out. Our next problem involves a surface area problem. And here we have a manufacturer of a firm wants to package its product in a cylindrical container which is 1 foot high with a surface area of 12 pi feet squared. What should the radius of the circular top be? And keep in mind that the surface area consists of the circular top and bottom and a rectangle that represents a side cut that is open vertically and unrolled. Basically, this right here is the equation for our surface area. That's the equation that we want to work with. Now keep in mind that we have that the surface area needs to be 12 pi square feet. 12 pi square feet. Okay? We have that h is equal to 1 foot. Okay, so we can go ahead and what we need to find is we need to figure out what r should be. So we can substitute these into our equation and see what we have. We will have that 12 pi is equal to 2 pi r squared plus 2 pi r times h, which happens to be 1, so right here it's just fine. Okay, we can actually notice here that we have common terms of pi. These will cancel out if we divide everything by pi. And also we can divide everything by 2. So actually we could have divided by 2 pi. The pi's will cancel. And also 2 divided by 2 will be 6. 2 divided by 2 is 1. So that 6 is equal to r squared. And then 2 divided by 2 here is also equal to, is just r. So we will have 6 is equal to r squared plus r. We want to go ahead and write this in standard form, and that would be r squared minus plus r minus 6 is equal to 0. And now we need to factor this. Now to factor this, we need to find products of negative 6 that will sum to positive 1. Okay, so we have negative 6. And how about if we look at 2, negative 2, and 3? Negative 2 times 3 is negative 6. Negative 2 plus 3 is negative 1. Okay, if that's the case, then this factors into r minus 2 times r plus 3, not 6. Let's write that again. R minus 2 times r plus 3 is equal to 0. And based upon the zero factor property, that means that r can either be 2 or r can be equal to negative 3. Okay, well, we cannot have a negative radius. Negative radius is outside the context of this problem. So this solution is extraneous, and and our solution must be r is equal to 2. Now, does that work out? Let's go ahead and find out. We will, if r is equal to 2, we are going to have that a is equal to 2 pi times 2 squared, which is 4, plus 2 pi times 2 times 8, which is 1. Well, 2 times 4 pi, 2 pi times 4 is 8 pi. 2 pi times 2 is 4 pi, and that happens to be equal to 12 pi. So that indeed works out just like a champ. Now, you will have a collection of problems that deal with applications of the Pythagorean theorem. And if you recall, the Pythagorean theorem deals with right triangles. No, right, in other words, triangles where one of the angles is 90 degrees. And what it says is that the square of the hypotenuse, which in this case is c, is going to be equal to the square of one leg plus the square of the other leg, or the equation is written down right here. And we can use these equations to solve problems such as example 3 right here. Now notice in this example we have a building that is 1 foot away from a fence. Here's the 1 foot that surrounds a property. And a worker wants to wash a window in that building which is 11 feet from the ground. So here's the window at 11 feet. So this distance is 11 feet. He plans on placing the ladder so that it rests against the building. And he decides that he should place that ladder 8 feet from the fence. So the ladder is 8 feet from the fence, which is 1 foot from the building, so it is actually 9 feet from the building. Okay? And the question here is, to the nearest foot, how long of a ladder would we need? Well, notice here, we have ourselves a right triangle. This leg is 9 feet. This leg is 11 feet. We want to know what this is. And let's just go ahead and call it, well, h, since it's kind of the hypotenuse. Okay? So using Pythagorean theorem, we know that h squared is going to be equal to 9 squared plus 11 squared. 9 squared is 81. 11 squared is 120. 81. 11 squared is 121. If you add those together, you are going, well, I forgot the 1 there. Let's try this again. 9 squared is 81 plus 11 squared, which is 121. There we go. And if you sum those together, you are going to get 202. So we have that h squared is equal to 202 feet. Therefore, h can be equal to either plus or minus 14.2 feet. Okay, well, we can't have a negative link for h. So h equals to negative 14.2. That is an extraneous solution. We can basically exclude that, and our answer will be h is equal to positive 14.2 feet. Does it work out? Yes, indeed it does. If you actually square this, you would get something very, very close to 202, which these would sum to. The next example is something that you're going to see in your homework, which is a little different. So I wanted to make it a point to go over it just to make sure that we understand how this thing works. Now, here we have the cost of a charter flight to Miami is $230 each for 75 passengers, with a refund of $5 per passenger for each passenger in excess of 75. And the question is, how many passengers must take the flight to produce a revenue of $16,770? So what we want to do for step 1 is find the number of passengers in excess of 75. So we want to find the number of passengers, and it's going to be in excess of 75. What do we do for step 2 for assigning a variable? Well, how about we let x be equal to the number of number of passengers in excess of 75. All right, cool. If that's the case, then the total number of passengers is going to be equal to 75 plus x. Makes perfect sense. The cost per passenger, and this right here is the crux of the problem, well, that's going to be equal to $230, and for every passenger over 75, each passenger is going to get a refund of $5. And how would that look like? That would be minus 5 times x. Okay, now we need to now come up with the equation. So for 3, it turns out the total cost of the flight is $16,770. What is that equal to? Well, it's equal to the cost per passenger, which is going to be 230 minus 5x times the number of passengers, which is 75 plus x. This is how you set up that particular problem. Once you figure this out, and this actually is the hardest part for this problem. Actually, I had to iterate on it a couple times before I figured it out. But once you set it up, you are pretty much off to the races. Now for step 4, we need to solve this. Now to solve this, first we can expand this, and if we do, we are going to have 17,250, that's basically 230 times 75, minus 145x, minus 5x squared is equal to 16,770. Okay, the very first thing we can do is we can get this in standard form by subtracting 16,770 from both sides, and if we do, we will then have 480 minus 145x minus 5x squared, and that's going to be equal to 0. Now I can divide both sides by negative 5 to get rid of the a term. And if I do, I will have x squared plus 29x minus 96 is equal to 0. Okay, now you might be tempted to go ahead and use the quadratic equation, but it might be a good idea to see if there are factors of 96 that sum to 29. So here, let's take a look at negative 96. And since you want this to sum to positive 29, let's take a look at negative 1 and 96. Well, that sums to negative, that sums to 95, so that's not going to work. 96, that sums to 95, so that's not going to work. What about negative 2 and 48? Negative 2 times 48 is negative 96. Unfortunately, that sums to 46, so that's not going to work. What about negative 3 times 32? Well, that product of that is negative 96, and its sum happens to be 29. So we can write this as x minus 3 times x plus 32 is equal to 0. Okay, if that's the case, then our potential solutions will be that x is equal to 3 and x is equal to negative 32. Okay, well, first thing is you cannot have negative passengers in excess of 75. As a consequence, this solution right here is extraneous and can be excluded, and the only other solution left is x is equal to 3. So you actually have 3 passengers in excess of 85. Okay, so the total number of passengers you have is 78. And does it work? Well, yeah, we can substitute 3 back into here, and if we do, we are going to have 230 minus 15, which is 215. We are going to have 75 plus 3, which is 78. And 215 times 78 is 16,770. So this does indeed work out. Now the next set of problems that you will see involve the height of an object. And the height of the object of an object in free fall is governed by this particular equation. It's going to be equal to 1/2 of the gravitational acceleration on Earth, which is basically negative 1,600 feet per second squared, times plus the initial velocity times time in feet per second, plus the initial height. And again, the negative 16 is associated with Earth's gravity, which in terms of SAE units is negative 32 feet per second squared. If you are from Europe, you're probably familiar with the negative 9.8 meters per second squared. Okay, and this right here is our problem associated with this. If a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, then the height of this object above the ground is governed by this equation. And the question is, how long will it take for this projectile to hit the ground? Well, this projectile will hit the ground when s is equal to 0. So the equation we want to solve is 0 equals negative 16t plus 100t squared. Now, what are we looking for? We're looking for the time when the time when s is equal to 0. We already have our equation. This is basically our variable for t, so we basically need to go ahead and solve t. Now, a problem like this we can solve by factoring. And of course, notice here we have a common, the values we have common in here are, they both have common factors of 4, and they both have common factors of t. As a consequence, we can write this as 0 is equal to 4 times t times negative 4 t plus 25. Okay, and then our solutions will be, well, 4 times t is equal to 0, negative 4 plus negative 4t plus 25 is equal to 0. Well, the solution to this is t is equal to 0. The solution to this one is going to be 25 is equal to negative 4t, no, positive 4t, my apologies, and therefore t is going to be equal to 25 over 4, which is equal to 6.25 seconds. Okay, now t equals 0 is the time when the thing was launched. It was actually launched from the ground at t equals 0, and that's what this corresponds to. So this is not the time when it returned to the ground. This is the time when it left the ground. So this is our extraneous solution. Therefore, this is the solution that we care about. This is the solution that counts. And if you think about it, it kind of makes sense, because with t is equal to 0, this is where we're at. Then it's going to go up by a certain amount, and then it's going to come back down, and that will occur at t is equal to 6.25 seconds. So this right here is our answer. Now, the one thing I do not have in here, but is in one of your example sets, is how many seconds will this thing hit 50 degrees above the 50 feet above the ground. So when will the object be 50 feet above the ground? Well, for this case, we are going to have that s is equal to 50. And our equation will be 50 is equal to negative 16t squared plus 100t. Once again, we can put this into standard form, and that would be negative 16t squared plus 100t minus 50 is equal to 0. Okay, now notice here we all of these have a common factor of 2, so if we wanted to, we could actually divide everything by 2, which is actually or divide everything by negative 2, which is what I want to do. So I'm going to divide this side by negative 2 and this side by negative 2, and if I do, I'm going to have, well, 8t squared minus 50t plus 25 is equal to 0. Now, unfortunately, this does not factor, so we would need to solve this using the quadratic formula. So we will have that a is equal to 8, b is equal to minus 50, c is equal to 25. And we will have that t, there will be two solutions, is going to be equal to 50 plus or minus the square root of 50 squared, which is going to be 2,500, minus 4 times 8 times 25, all divided by 2 times a, which in this case would be 16. Now, if you solve this, and I'm sorry, I'm not going to do this for you, you will get two solutions. Both solutions, and the first solution will be that t is equal to 0.548 seconds, and that would be t1, and that t2 would be equal to 5.702 seconds. And does that make sense? Well, yeah, actually kind of does. Here we launched the object. Okay, now here is 0. Let's suppose that this right here is that this line right here is 50. When you launch the object at 0.5 seconds, right here, t1, it's going to cross 50 meters. It's going to then hit its vertex and come back down, and when it comes back down and crosses 50 meters, or 50 feet, not meters, you will have t2, which is 5.7 seconds. So it actually does work out. Both of these solutions are valid. The next example that I want to share with you is consecutive integers. So here we have that the difference of the squares of two positive consecutive even integers is 12. Find the integers. Use the fact that if x represents one even integer, then x plus 2 represents the next even integer. Now there's a couple ways to do this. Here's probably the way that you want to do it. Okay, so we are going to use the difference of squares of two positive consecutive even integers. Well, the smallest positive even integer is 2. The next positive even integer is 4. 2 times 2 squared is 4. 4 squared is 16. 16 minus 4 is 12. So those are your two consecutive even integers. The other way to do this is to notice that one integer is going to be x, the next integer is going to be x plus 2. Okay, the square of x plus 2 is x plus 2, well, the entire quantity squared, and the square of this one would be x squared. The difference is going to be x plus 2, the entire thing squared, minus x squared. If we simplify, and that's going to be equal to 12. We can expand these, and if we do, we will have x squared plus 4x, because that is a perfect square, plus 4 minus x squared is equal to 12. Well, these like terms cancel. We will have 4x plus 4 is equal to 12. All right, cool. We can subtract 4 from both sides, and if we do, we will have 4x is equal to 8. Dividing both sides by 4, we have x is equal to 2. So either way works. Of course, if this number is disgustingly large, you might want to use this approach, but since they're relatively small numbers, you can just go ahead and knock it out like this. Okay, and then our last example is basically modeling. Now here we have the IRI trolley service carries passengers along International Drive in the resort area of Orlando, Florida. And we have a bar chart. We don't really need to see it. It's not that important. But what is important is this quadratic equation, which models ridership from the year 2000 to the year 2010. And of course, x equals 0 represents 2000, and then all the other values of x are years after 2000. So x equals 0 is 2000. X equals 10 is 2010. Therefore, this model is only valid from when x is equal to 0 to x is equal to 10. If it's outside that range, this model does not apply. So the first question is to determine the model ridership for the year 2008. Well, in that particular case, x is equal to 8. Okay, so we just go ahead and put the numbers in and see what we get. We will have that y is equal to negative 0.0072 times 8. Plus 0.1081, oh, I'm sorry, 8 squared, times 8, plus 1.619. And if you knock that out in your calculator, you are going to get 2.023, and that will be your ridership in millions in the year 2018, in the year 2008. Okay, now the next one is, according to the model, in what year did the ridership meet 1.9 million? So for this one, we have that y is equal to 1.9 million, and we need to figure out what x is. So that's going to be here we need to solve the equation 1.9 is equal to negative 0.0072 x squared plus 0.1081x plus 1.619. Now to solve this, you're going to need to use the quadratic equation. And of course, the first thing you would need to do is put this in standard form. Putting this in standard form, you are going to have negative 0.0072x plus 0.1081 1081x, this should be x squared, my bad, minus 0.281. Now to solve this, you're going to have to use the quadratic equation where this right here would be A, this right here would be B, and of course that would be C. Now if you solve it, and I'll let you work that out on your own, what you will find is that x will either be equal to 3.3444 or x is going to be equal to 11.670. Okay, now notice that this model is only valid between the year 2000 and the year 2010. X equals 3.3444 corresponds to 2003. This corresponds to 2011, which is outside of the range. So this solution is extraneous, and the only solution that applies to this particular model is this model right here, which would imply that the ridership reaches 1.9 mil in the year 2003. And that is all I have for this particular video. If you have any questions, please feel free to reach out. This is Bob Boyle, signing off.